Hello students, welcome back to the lecture series of vectors. This is our lecture number 3 and in this lecture I am going to discuss about the scalar product of vectors. So let's get into the video. So actually in vector there are two types of products. One of the type is known as scalar product and the second type is known as the vector product. Scalar product means the final result of the product comes as scalar number, and vector product mean the final result of the product will come as a vector quantity. So first you write this one. There are two distinct kinds of products in vectors. One being a pure number called the scalar product, and it is also known as dot product, while the second one is a vector quantity and it is called the vector product of the vectors. And then we are going to discuss about the scalar product in this video, and in the next video we will discuss about vector product or cross product. Okay, so the scalar product means if you have two vectors, say a bar and b bar, you have two vectors a bar and b bar and having theta be the angle between them, then you see here the scalar product is defined in this way. Just a minute. Scalar product is defined in this way. If you have two vectors, say a bar is a vector and b bar, this is the second vector, then the scalar product of these two vectors is denoted by, denotation is a bar dot b bar. Dot should be visible, and it is defined as it is equal to modulus of a bar, then modulus of b bar, and then cos of angle between the two vectors, mean theta. So this is the definition of dot product. Now you write it. You write the definition. The scalar or the dot product of two vectors a bar and b bar is denoted by this symbol a dot b. Dot should be visible, and it is defined as, I already told you, this is a dot b is equal to mod a, mod b and cos theta, where theta is what? Where theta is the angle between the vectors a bar and b bar. This product is positive if the angle between the vectors is less than 90 degree, because in that case the angle will be in the first quadrant, and in first quadrant cos is positive. Therefore that final dot product is positive when the angle theta is less than pi by 2, and the dot product will be negative if the angle between the vectors is greater than pi by 2, because if theta is greater than pi by 2, then cos theta will lie on the second quadrant, and in second quadrant cos is negative, and so the dot product is also negative. And this dot product will be equal to 0 if the angle between them is pi by 2, mean if the two vectors are mutually perpendicular to each other, then the dot product of the vectors is equal to 0, because cos pi by 2 will be 0, therefore the entire product is also equal to 0. So next you see. So now we discuss about properties of scalar product. So what are the properties? You see here, number 1, the scalar product is commutative. Commutative mean, it is very simple. Commutative mean if you have a bar and b bar, these two vectors, then why it is commutative? Because a bar dot b bar, this is actually what? A bar dot b bar is equal to, it is modulus of a bar, then modulus of b bar, then cos theta, and that can be obviously written in this way: modulus of b, modulus of a, then cos theta, and it is obviously b dot a. So we see that A dot B is equal to B dot A. Then the next one, the scalar product is distributive over addition and subtraction. What is this? This one is like this. You see, if you have three vectors A bar dot B bar plus C bar, three vectors in this way, then it will be equal to A bar dot B bar then plus A bar dot C bar. Very simple. Then it may also be for the negative sign also. That means if you have A bar dot B bar minus C bar, then what about this? It will be equal to A bar dot B bar minus A bar dot C bar. So this is the distributive property of dot product over the addition and subtraction. So you write that one. Then number 3, if m is a scalar number, then m into a dot b is equal to ma dot b, or it may be equal to a into a dot m into b, and that is also is equal to a dot b is equal to a dot b into m. It is obvious case. Then the next one, the scalar product of two non-zero vectors is 0 if and only if the vectors are perpendicular to each other. So this question, this may be asked in your exam, so try to prove this. You see here the proof. So first of all, take the angle between them. Say let the angle between them is theta, and in the first case let theta is equal to pi by 2, mean if they are perpendicular to each other. Then A bar dot B bar is equal to what? Then A bar dot B bar, very simple, it is modulus of A bar then modulus of B bar then cos of pi by 2, because angle is taken as pi by 2, and cos pi by 2 is obviously 0, is equal to 0. This is the first case. And conversely, if you take the dot product is 0, then they are perpendicular to each other, and that can be proven this way. You see, case 2 you write in this way, let, or conversely you can write conversely let A bar dot B bar is equal to 0, and this is implies A bar dot B bar is obviously mod A bar mod B bar cos of theta is equal to 0, but A, B, these are non-zero vectors, therefore cos theta is equal to 0, and which will imply theta is equal to 0, and theta is equal to pi by 2, not 0. Theta is equal to pi by 2. So there are two cases. If first of all you take pi by 2 is equal to 0, then show that dot product equal to 0, pi by 2 equal to first of all you say theta is equal to pi by 2, that is angle between the vectors are pi by 2, then you have to show that dot product is 0, and conversely you take the dot product is equal to 0, then you have to show that theta is equal to pi by 2. So I think you understood this. Then we take the next one, A dot A, this is mod A then cos 0, because direction of A and A are same, and therefore the angle between the two vectors will be 0, therefore it is cos 0 only, and hence the dot product is equal to mod A cos of 0, and this value cos 0 is 1 only, and mod A is also A is equal to simply A square. And then the next one, we know that I cap, j cap and k cap are three mutually perpendicular unit vectors. Their unit vectors, I cap is along x-axis, j cap is taken along y-axis, and k cap is taken along z-axis. We already know this. Then I dot j, these values to be written here. You see, I dot I is equal to obviously mod I cos 0. Cos 0 is 1, but modulus I is equal to 1, modulus I is equal to 1, because they are unit vectors. Actually mod I into cos theta, mod I is 0, mod I is equal to 1, mod I is equal to 1 again, then cos theta is also 1, so 1 into 1 into 1 will give us 1 only. In the similar way, j dot j, this is also is equal to 1, this is mod j into cos theta, and all of these three results is equal to 1. In the similar way, this is equal to 1, but I dot j is equal to 0. Why it is equal to 0? Because I and j, they are unit vectors, and they are perpendicular unit vectors. Therefore perpendicular vectors dot product is equal to 0. So I dot j equal to 0, j dot k equal to 0, and simply k dot I is also equal to 0. You understood this? Then the number 7, if two vectors a bar and b bar are in the same direction, that means the angle between them theta is equal to 0, then a dot b is equal to ab. Why it is a dot b equal to ab? Because you see simple a bar dot b bar, they are of the same direction, so it can be written as modulus of a, then modulus of b, and cos of angle between them is 0 because they are in the same direction. Mod of a is simply a, mod of b is simply b, and cos 0 is equal to 1. So a dot b is equal to simply ab, simple product. Okay, then if two vectors a bar and b bar are in the opposite direction, then theta is equal to pi, and in that case a dot b is equal to minus ab. Very simple, because cos pi will be equal to minus 1. Just put in the previous one as cos pi, and cos pi is equal to minus 1, so the result will be simply minus ab. Okay, then the next one, angle between two vectors. So if you have two vectors a bar and b bar, non-zero vectors a bar and b bar, as like this, a bar is equal to a1 I cap, b1 j cap, and c1 k cap, and b bar is equal to a2 I cap, b2 j cap, c2 k cap, b2 non-zero vectors actually. Then we also take theta be the angle between these two vectors, so theta be the angle between two vectors. Then we have the formula for a dot b is this one, and from here cos theta will be is equal to a dot b divided by this term will divide here, divided by modulus a modulus b, and from here we can find the angle between the two vectors. And before that you are to complete the dot product here, and it is simply a bar is equal to this one, b bar is equal to this one, mod a mean modulus of this vector, and mod b mean modulus of this vector. And if you complete this product, a1 dot a1 sorry a1 dot a2 mean it is a1 a2 is the scalar part, then I dot I is equal to 1. Just expand this product. So a1 a2 I dot I is equal to 1, then a1 b2 I dot j will be 0 because I cap and j cap are perpendicular unit vectors, so 0. Similarly, I dot k, that is a1 c1 a1 c2 I dot k, that is also 0. Then start with b1 b1 a2 j dot I is 0, but b1 b2 j dot j will be equal to 1, so b1 b2 will remain there. Similarly, b1 c2 j dot k will be 0. Then start with c1 a2 k dot I is 0, c1 b2 k dot j is also 0, c1 c2 k dot k is 1 only. So we have only three parts, a1 a2, then b1 b2, and then c1 c2. Other terms will be 0. So I am writing that one, a1 a2 plus b1 b2 plus c1 c2, and divided by the modulus of this vector is simply root over of a1 square b1 square c1 square into modulus of this vector is a2 square b2 square c2 square, and this is the from here you can find the angle between the two vectors a bar and b bar. Okay, so let me take the next one. we are writing a note here. Already we know from the previous screen that cos theta is equal to this one, but if you have the angle between these two vector is pi by 2, that means this theta is pi by 2, then what we will get? So if the vectors are perpendicular to each other, then theta is equal to pi by 2, and so cos theta will be equal to 0. And when cos theta is 0, then this expression will be equal to 0. And if this expression is equal to 0, then by cross product you can say a1 a2 b1 b2 c1 c2 is also equal to 0. So this is also equal to 0, and this is known as the condition of perpendicularity of two vectors. This is the condition of perpendicularity of two vectors. And the next one, so one important thing is here, projection of vector, one vector on the other vector. This is the topic now. So what is projection? First you see the figure here. So if you have two vectors OA bar, and that is taken as A bar vector. So let me take the pen tool. You see here, if you have two vectors OA bar, this vector is taken as OA bar, this vector is taken as A bar, is a non-zero vector. Similarly, OB bar, this vector is taken as B bar, and both of them are non-zero vectors, and we have the angle between these two vectors as theta. And then you see what is projection. Projection mean, first of all, say I am taking projection of this A bar vector on the projection of B bar vector. So what to do? Then you have to take a perpendicular from the first vector of which you are taking projection, of the first vector from the head of the first vector. You have to draw a perpendicular on the second vector, that is on B bar, as like this, as like in the figure. From the head of the first vector, mean I am taking the projection of A bar, so you are to draw perpendicular from the head of A bar on the vector B bar, because we are taking projection on B bar, that is AM. You see the figure, AM is a perpendicular drawn on the second vector B bar. Then the length OM is called the projection. This length OM, not the vector OM is called the projection. Projection of what? Projection of A bar, projection of A bar on B bar. Very simple. So this term, these are written here in typing. You see here, let OA bar is equal to A bar, OB bar, this is equal to B bar. Then these are two non-zero vectors, and theta be the angle between them. Then we draw the perpendicular AM. This AM is perpendicular from the head of the first vector, mean whose projection we are taking, on the second vector, that is on B bar. Then this length OM, modulus of OM actually, and that is simply OM, is called the projection of the vector A bar on B bar. Now you see, from the triangle OAM, you don't think about this vector sign, just you have the triangle OAM, and from this OAM and OAM triangle, what can we conclude? We see here this OM divided by OA. What is this? Is it not is equal to cos theta? This is cos theta. Then what is the length OM? Length OM is equal to simply OA, this OA cos theta, is not it? And OA cos theta, this OM mean modulus of OM, and this is projection of A bar on B bar, projection of A bar on B bar, and that is equal to, what about OA? This OA is nothing but modulus of A bar and then cos of theta. So projection of A bar mean you are to multiply by mod A on some vector B bar, then into cos of angle between the vectors a bar and b bar. Very simple. The projection of a bar, then you are to multiply mod of a bar on b bar, angle between a bar and b bar, then take cosine, is the projection of vector a bar on b bar. If you want to find the projection of b bar on a bar, then what about that? In that case, projection of b bar on a bar, I am writing here projection of a bar on b bar. Then what is this? This is, sorry, not projection of a bar on b bar, I am really sorry, I am taking projection of b bar on a bar. Projection of b bar on a bar, what is this? So I am taking projection of b bar, so you multiply b bar mod into cos of angle between the vectors, mean theta. It is mod b cos theta only. Is that clear? So you write the notes. So from triangle OAM, we have OM is equal to this one, already I discussed with you. Then projection, this OM length is called the projection of a bar on b bar. So I am writing in word, projection of a bar on b bar is equal to, it is simply mod of a into cos theta. So again, from the definition of dot product, you see, from the definition of dot product, a dot b is equal to mod a mod b cos theta. Then from this one, mod a mod b cos of theta, it is equal to what? It is equal to simply a dot b, just from the previous line. But we can write in this way, because a cos theta, mod a cos theta, this is projection. So I write here mod a cos theta in the left hand side, and this is equal to, right hand side will be equal to simply modulo a bar dot b bar divided by this mod b bar will be denominator of the right hand side now. So you can find this projection of a bar on b bar in this way also. This is also one of the alternative way to find the projection of a vector a bar on b bar. So projection of vector a bar on b bar mean, you should remember this as projection of a bar on b bar, then take the dot product between them. On b bar mean write denominator mod b bar. Projection of a bar on b bar is this one. If you want to find the projection of b bar on a bar, then first find the dot product of the vectors a bar dot b bar. Then this time I am taking projection of b bar on a bar. On a bar mean you write a bar here, a bar as the denominator. So on b bar, projection of a bar on b bar. On b bar mean you write module a dot b as the numerator of b bar. Then on a bar you write a dot b as the numerator of a bar. On b bar mean you write the numerator of b bar as a dot b. On a bar mean you write the numerator of a bar as a dot b. Is that clear? Hope you understood this. You see the written line, this mod of a cos theta is equal to a dot b divided by mod b, and this is nothing but projection of a bar on b bar. So I write projection of a bar on b bar, because mod a cos theta is here, mod a cos theta will give us the projection of a bar on b bar, and this is equal to this. Is very important one. Frequently in your exam asked these types of problems in the earlier years, and it may also ask in your final exam also. So the next topic is components of a vector a bar along b bar. You see here, first of all I am taking this figure. I am taking this figure in the earlier case. This time the component of a bar along b bar. So first, to find the component of the vector a bar on b bar, first of all you find the projection. That means I can write in this way, that component vector, that is component of a bar on along b bar, it is equal to you are to write the projection of A bar on B bar first, that is OM. That means it is simply A bar dot B bar divided by modulus of B bar. This is the magnitude of the vector component. Magnitude of the component this into this total quantity, this bracketed quantity is a scalar term actually. You see, it is a scalar term, that is it will give the value of the component. Then to make this as a vector in the direction of B bar, I am taking here a unit vector in the direction of B bar, and that is simply B bar by mod B bar. It is actually B cap. Okay, so to find the component of the vector A bar on along B bar, first you write the projection of A bar on B bar, and then you multiply by a unit vector in the direction of B bar. So it can also be written as A bar dot B bar divided by mod B into mod B will give us mod B square, and it is along B bar, so you write B bar. So this is component of A bar along B bar, and it can also be asked in this way, and this is also known as, actually it is also known as projection vector. It is also known as projection vector of A bar along B bar. Along B bar, projection vector of A bar along B bar and component of A bar along B bar are same thing. Hope you understood this. Then what is the component of the vector A bar perpendicular to B bar this time? This already we discussed along B bar. Now what will be the component of the vector A bar perpendicular to B bar? And that is obtained from the triangle OAM. You just observe the triangle OAM, and from OAM, what is this? From OAM you see OM bar, from you write here in this way, from triangle OAM, you write from triangle OAM, OM bar plus MA bar is equal to OA bar, and among this which one is perpendicular to B bar? Obviously MA bar, it is perpendicular to OM bar by OB bar, and so this can be written as, we have to find MA bar now. MA bar is equal to OA bar minus OM bar, is not it? And OA bar, it is simply A bar minus OM bar. OM bar is nothing but the projection vector of A bar on B bar, and that is already obtained in this previous line. You see, it is simply A dot B divided by mod of B square and into B bar. So this is the projection. It is the not projection, it is the component of A bar perpendicular to B bar. These two things you should be written right in your copy: component of A bar along B bar and component of A bar perpendicular to B bar. Okay, so today we finish this class here, and in the next class I will take the problems of dot products or problems of scalar products. That means we have to solve the exercise number 10.3 of NCERT book, and after finishing the NCERT book I will take some extra questions from a CBSE final exam or from different board exams of India. So let us finish this class here. Thank you very much.